going to look at, in these couple of videos, a couple of different ways to solve limits algebraically. The first way that we're going to look at is going to be solving a limit by factoring. Now, we're going to look at the one on the next page here, and we're going to see exactly why we'd want to factor it, and then we'll also know when to factor it. So we've got this limit here. The limit is x approaches 5 of x squared minus 3x minus 10 all over x squared minus 25. So we're going to try direct substitution. And the reason we're going to do this is because it is by far the easiest way to evaluate a limit if we can do it that way. So let's start with that. We just substitute in 5 here for x. We get 5 squared minus 3 times 5 minus 10 all over x squared minus 25. This numerator equals 0, denominator equals 0. We have 0 over 0. Anytime we have 0 in the denominator of our fraction, we cannot do it. So this way doesn't work. No good. So let's take our limit here again, our original limit, and let's give it a shot by factoring it. Now we can factor this. We've got a quadratic in the top. We have difference of squares in the bottom. This is a rational function. We've seen these before. So let's simplify it, factor it. So if we do that, get that out of the way, we get the limit as x approaches 5 of, numerator here is going to be x minus 5 times x plus 2, because negative 5 times 2 is negative 10, negative 5 plus 2 is negative 3. And our denominator is a classic difference of squares, x minus 5 times x plus 5. And here we have these factors here, same on the top and bottom. They simplify out, divide to 1, cancel out, whatever you want to call it. So we're left with the limit as x approaches 5 of x plus 2 over x plus 5. Now, let's try substituting this in again. We get 5 plus 2 over 5 plus 5, which is 7/10. So our original problem here, the limit as x approaches 5 of x squared minus 3x minus 10 over x squared minus 25 equals 7/10. Now, the reason this works this way is because in the denominator up here in our original function, there are two values that are going to make the denominator 0, if x is 5 or if x is negative 5. But when we factor it, we can see that the thing that would make our limit, when we substitute in 5 minus 5 is 0. That factor cancels out, simplifies out of the numerator and the denominator. So since that happens, that doesn't mess up or cause 0 to be in the denominator of the simplified form. And since these are equivalent, this factored form is equivalent to the original function at any point except when x is 5. We can do it like this because we don't care what the function is at x equals 5. We want to know what it's like as it gets to 5, as it approaches 5. And as it approaches 5, even though we can't actually have it at 5, as it approaches 5, we approach 7/10, and that's our limit.